Hello, welcome back to my bench. Today we're going to finish off with this Harris limiter. I was told, one of my viewers commented that they believe that this is one of the newer versions from late 70s, early 80s. And I went out looking for a new manual and I found one, and indeed it is from 78 to 80 something. I don't know when. There's no mark on inside here at all. I can't find anything that has a date code on it anywhere. Anyway, but it does have the points and the adjustments that correspond with this new manual. I kind of got confused when I looked over the other one because I couldn't find some of the points that it was telling me to look at. So we have the manual that matches it. We're going to test that out. So I changed out a couple of caps. I tested all of the capacitors, all the resistors in here to the best of my ability. They all look good. I changed out this cap right here, this C17. It was flat out open, and I checked this one over here, this C18, and it was flat out open too. The rest of them tested absolutely perfect, with the exception of that C22 in the back, which I went through. I said, what the heck? I tore apart the big old can here and stuffed a 220 at 450 volts, because that's what I found. Stuck it in there. It fit perfect, so I've got that all nicely put back in, and it looks more or less original. And now we're going to do its little alignment just to make sure that the thing is where they say it is and what it'll work. So the first things we're going to do is we're going to look at the schematic up here, and we're going to go and check the power supply, the 39 volts. So the 39 volts, it says locate resistor R77, which is right down here. We'll show you. And check the power supply of 39 volts at the positive terminal of C26, which is over there. All right, so get the meter up here. I'm already plugged into ground. We'll check the voltage here. And we're looking at, wow, 39.02. That's pretty good. I don't even think it needs adjusting, but we'll adjust it anyway, just to show you. A little bit of gunk in the thing. Okay, so we go at 39. That was cute. I just shorted it out. Probably not a good thing for it, but so we got 39. Oh, a lot of slop in this 10-turn pot. Come on. Wow. There's like a turn, almost a whole turn between when you go backwards to what the direction you were going. Oh, 39.018. We'll leave it there. That's good enough. All right. So there's our first one. This second one here, it says to look for select variable resistor R82. Set the no signal voltage across resistor R84 at 25 millivolts plus or 5 millivolts. Well, I looked into this a little bit before I got on here. We can't really do this one because if you look, R82 is right there. It's not a variable resistor. It is a picked resistor, which is 169 ohms. So they replaced that resistor with a fixed resistor for what they wanted at the factory. That resistor measures correctly, so I'm not going to mess with it at all. So we'll go on to the next one. The balance referring to figure 5.1. Locate resistor R8. R8 is over here. Balances Q1 and Q2 for the lowest harmonic distortion, which is right here. And down past the picture. And this is done at a signal level of 10 kilohertz with 10 dB of limiting. So let's get the function generator up here. Let's put that is on 10 kilohertz, but it not really. You have to tell it first. And it says 10 volts, but it's not. I want, well, I don't know. Let's try 6. 4. Okay, I'm watching the meter here. 5. Okay. 5.5. Okay. 5.5 is exactly 10 on the meter. And we want the output to go to the distortion analyzer, I think. Yeah, so we want the distortion analyzer at 10 kilohertz and bring up the scope. Come on, scope. Where'd you go? Oh, my scope died again. It does that periodically when it wants to. All right, so there's the scope. And we want channel 2. Turn off channel 1. Bring channel 2 down. Stretch this out a little bit. Okay, there's my 10 kilohertz signal. And according to the distortion analyzer, all we got to do is turn. Okay, what did I do with the... Here it is. All we got to do is turn R8 for the minimum amount of distortion. Whoops. So what you want to watch here is watch the height. So what we want to do here is to turn this R8 and you watch this output of the distortion analyzer. This is the product minus the... It's what the distortion analyzer puts out to show you how distorted your signal is. And we'll turn this R8 at 10 kilohertz and you watch. See the distortion go up, down, back up a little bit, down. I can watch the meter here, and right there is absolute minimum for distortion at 10 kilohertz and 10 dB signal. All right, so that's that one. Now let's see. The next one is sensitivity. Variable R36. This component determines the sensitivity of the automatic peak phasing and should be factory adjusted so that the phasing at K1 does not clatter when operating with 10 dB of limiting at 20 hertz. All right, so let's put the function generator back up here and take this guy to 20 hertz. All right, there's 20 hertz. And we want to turn R36, which is back here. Which way is which? It's turning the control in counterclockwise direction from the factory adjusted point increases sensitivity, and in clockwise direction decreases sensitivity. So we want to turn it down until the thing clatters. Whoop. There. Can you hear it? Click. All right. Turn this back down. One again. And a little more. Okay. So that's right. That thing is quit clattering. Now, what's next? So the automatic phasing. So phasing, we need to check field effector Q12 must be properly biased in order for the automatic phasing section to operate correctly. Since all FETs are different on how much you put in the, how much you put on the base, the gate of them. We have a bunch of diodes lined up in line here, and in this one, only 2 of them are used. There's 4 here. 2 are just got a jumper across the top of them. So we'll take the meter and we'll check and see what our voltage is on the gate, which is the center one on here. Oh, wait. Get rid of level, okay? And we'll take a measurement there. And it's 7677 and climbing. It says between 8.5 and 10.5 volts. And it is climbing. We'll see what it stops at. Eight 8.9. There we go, 9.2. 9.3. It's slowing down drastically. 9.4. Yeah, we're going to call that 9.5. Okay, so that's fine. That's within its range. So we're happy there. Okay, so now we're going to do the meter calibration. And this one, we've got to use a couple of pieces of equipment here. I've got a meter over here that I can read my output with. It's my old HP, what is this thing? 403B. All right, so it says determine limiting threshold by increasing the input level, signal level, and observing the meter indication of the output signal. In our case, we're going to use the scope until it stops rising. So if we go back to the scope and the droid meter here, or the thingy here, we're going to raise this up until the scope level stops raising up. So let's see where it goes normally. Let's, I don't know, give it 6. All right, so it's going right to here, right to that line, right there, okay? So about 5.13 peak to peak. All right, so if we go over to here, take this back down to 0, and just start raising it up until it gets right. Okay, that's too much. That's 0.64. Oops, it dropped a little. Maybe a tiny shade. Yeah, it's dropping a tiny shade. 4.24. So it looks like 0.6. All right, so 0.6 volts on my meter is reading minus 13. Okay. So that means I got to go to plus or minus 3. So we'll take this up. Minus 3 should be, I don't know, we'll try 5. Yeah, that's 4. Try 6 and get, whoa, didn't like that. Try 6. There, minus 3. And we adjust R60. Get the camera going for the droid cam. Opt. All right. That is off a little. We want it to be 10 dB. Oh, touchy. There we go. 10 dB. Perfect. So, we have adjusted all of those. And I think that's it. Yep, all the rest of it's troubleshooting guide. So, if we go get rid of some of this stuff, the function generator, and the scope. All right, so basically, we're done with the alignment of this. Now, I want to check and make sure that it's doing what it's supposed to do by watching the meter and seeing what it does. So, if we take the function generator here, and, well, wait a minute, let's see. Let's go back here, get the function generator on, and the droid cam on. Yeehaw! All right. So if we watch the meter, and we change the output from, delete that, should drop down to 0. Why do you not like being focused? Focus. Doesn't like being focused because of the stuff behind it. All right, we'll do that. Now we can't do that. All right. This is fun. All right, I guess that's a little bit better. All right, so let's give it 4. Well, I got to be on the thing to give it 4. Let's give it 4 volts and watch the meter. There we go. Yep, it went up and sort of leveled out on its own. That's great. Let's see what happens with the scope. All right, there's the scope. Let's take it back down. Let's start off with 2. That's still leveling it out at 1. Okay, 1, and it's going up. And it just stops. So let's bring it down. Okay, there you are at 0.57. And we want to see if it, when I go up, we'll give it a 1.57. And what we want to see is right here that it doesn't go above this dotted line when I hit it with, I don't know, 2.57 volts. Ready? Here we go. It would help if I was in the thing. It didn't do anything. Here we go. Ready? Well, it went a little above it. Let's try 3. Okay, so 357 did nothing. 1. And went down and came back up. It's trying, but when I hit 2 volts, 2.5, it doesn't do anything. So it is doing what it needs to do. The only thing it's changing, if we go back to the droid cam here, the only thing that's changing when I do that, take this, delete this, backspace, there we go. It drops down to nothing, but if I give it 2 volts, it says that's 5 dB. So that's 5 dB of of clip limiting. Get rid of that, and I'll give it 6. Now we're at 10 dB of clipping, with the output never rising. So that is correct. It is doing exactly what it's supposed to do. That's nothing right there. All right, so perfect. It works. The whole thing works just like it's supposed to. Great. I'm happy. I did clean the pots in here, and let me tell you, that wasn't easy because these are those Bourne's sealed up pots, and you just sort of got to spray them until something gets inside and then work the heck out of them. Anyhow, there you go, guys. This thing is done working. I'm going to get it back to the guy that owns it, and he should be happy. One thing that I want to bring up here is I have the other side of this, which is the AGC unit. Looks just like it, the same kind of box of design. However, I can't find a manual on that thing to save my life. It's just not out there, so we're going to just have to play with it and guess. But that'll be coming in shortly. It's just going to be a wing it kind of repair. So, hey guys, thanks for stopping by. This thing's done. I'm happy with it, and I'm sure the guy that gave it to me to fix it would be happy with it too. So, thanks for stopping by, and don't forget to subscribe, ring the bell if you like, and see when I'm doing this stuff, and give it a like if you like it, and talk about it in the comments. So, until next time.